something I'm going to try and make an effort to do this semester is to put more of these YouTube videos on a regular basis, maybe once a week or every other week or something along those lines. These are some nomenclature examples from the handout that's on D2L. Now again, that handout is optional. It's basically to help you study. I'll post the full answer key a little bit later in the semester, but I want you guys to be working through it, and if you're not sure, ask me questions. But I will give a few of the examples for nomenclature, and I'll try and keep these videos relatively short, so that way I don't spend too much time babbling. All right, so sodium sulphide. Sodium is a metal, sulphide is a nonmetal. Sulfur becomes sulphide. You should have a periodic table as you work through any of these type of problems. The chemical symbol for sodium is Na. Again, the lowercase letter, I'm sorry, the second letter is always lowercase. Sodium is in group 1. That means it forms a positive 1 charge. Sulfur has the chemical symbol of S, and it forms a 2- charge, an anion. To get charge neutrality, we need to have 2 positive charges and 2 negative charges. And again, by cross multiplication, you can write this out formally. I'm not going to do that right now. We covered that in class. The lowest common denominator is 2, so 2 sodiums, 1 sulfur, and that gives me Na2S, sodium sulphide. You can leave the charges or erase them. They don't matter. If you want to make it look cleaner, you can just rewrite it like that, which is fine. Indium One Iodide. Indium is in group 13 on the periodic table. What that means is it can have a +1 or a +3 oxidation state, a charge. In this name, you're explicitly told this is Indium 1, so there's no ambiguity. Indium has the chemical symbol In. It's +1, which again comes from the name. Iodide is from iodine. And again, this, sorry, get a little squished in here. The capital I is the symbol for iodide, and it has a -1 charge. I know it has a -1 charge because iodine is in group 17. +1, -1, we have charge neutrality. It's a 1-to-1. So to make this look a little neater, especially how badly I'm drawing this, writing this, INI. Again, it's understood that there's a subscript of 1 and 1. You don't have to write that out explicitly. +1, -1. If it was indium 3 iodide, then the formula would change. Then it would be INI3. I would either have to give you the formula, and then you would give me the name, Indium One Iodide, or, like I said, give you that information in the name itself. I can't simply say indium iodide, because it could be +1 or it could be +3. Iron to bromide. The transition metals have the same issue in that they can form multiple charges, multiple positive charges. So in the name, I have to tell you this is iron 2+. The chemical symbol for iron is Fe. Again, it's my expectation that you'll get used to interchangeably looking at the name and the symbol as, again, we progress through the semester. Look at your handout and your notes as far as my expectation of what elements you should know at this point. Bromide is from bromine, So Br. Bromine is in group 17 as well, so it's also -1. We need charge neutrality. Iron is +2, the bromine is -1. So we're going to have 2 bromides. And again, I'll just rewrite it to make it more clear. If I gave you the formula, again, you would have to write out iron 2 bromide. If you just wrote iron bromide, it could be iron 1 bromide, iron 2, iron 3, iron 4, and so forth. So you must be explicit in the names of transition metals and group 13 elements and some of the group 14 elements like tin and lead, but we haven't talked about tin and lead specifically. Chromium 3 chloride. Chromium is also a transition metal. Its symbol, Cr. It's going to be 3+. And again, writing the number, then the charge is just a nomenclature thing. If you write it as +3, I'm not going to get upset about that. Chloride. And again, chloride is in group 17, like iodide and bromide, and so it's also going to have a -1 charge. Chromium 3 chloride. Chloride is from chlorine. So +3 -1, we cross multiply, and we're going to have 3 chlorines to 1 chromium. So CrCl3. Now, watching me do this makes it look very trivial, but you want to take the time to go back through. Actually, apparently it's not trivial for me because I don't know how to make a proper R. Take the time to go work through not just these problems, but the rest of them on that handout. Because it's one thing just to watch somebody name the elements. Okay, yeah, sure, I'll remember them. But if you don't do it yourself without looking at your book or having somebody tell you, you might forget what the symbol for sodium is, or indium, or some other element. So take the time, get used to looking at the periodic table, symbols and names, names and symbols, get used to them, as well as the charges. And the only way to do that is by practice.